Here we are going to discuss about the internal and external characteristics of separately excited DC generators. Already we discussed about the no load saturation characteristics or open circuit characteristics of this type of generators in the previous video. Here we are discussing about the rest two characteristics of that type of generators. Okay, internal and external characteristics. For internal characteristics, it is the type of characteristics that will give you the relationship between E and IA. What is E? E is nothing but the voltage appearing across the brush terminals of the armature and the armature current, that is IA. We know that the voltage available at the terminals of the armature will be always less than the generated EMF, that is EG, because the voltage drop due to armature resistance, that is IARA drop, and the voltage drop due to armature reaction, that is here we can consider the demagnetizing effect of armature reaction. Due to these two voltage drops, we will not get the exact generated EMF at the terminal of this brushes. Okay, so the internal characteristics will give you the relation between E and IA, and E is equal to EG minus, EG is the generated EMF in the armature, and EG minus voltage drop due to armature reaction, that is demagnetizing effect of armature reaction. So E will be always less than EG. Okay, but the important point is that this internal characteristics is mainly decided by the designer, because we cannot measure this E or the voltage appearing across the brush terminals by using a voltmeter, so that these characteristics or these specifications are mainly designed by the designer. Okay, and it is not very much important for considering a particular generator for a particular purpose, the internal characteristics. But the important characteristics is the external characteristics. Okay, that will give you the relationship between the terminal voltage and the load current. Okay, the terminal voltage is mainly depends on the voltage drop due to armature reaction, voltage drop due to the armature resistance with along with this EG. Okay, that is V can be written as V is equal to E minus IARA, and we know that this E is equal to EG minus voltage drop due to armature reaction, so that we can say that in external characteristics the terminal voltage includes both two drops, that is due to armature reaction and the voltage drop due to armature resistance, so that V will be very less compared with the value of E and EG. Okay, terminal voltage will be always less than EG due to these two effects, two voltage drops. For plotting this external characteristics, you can use these experimental setups. Here, the field windings are excited from the external DC source, and before doing this test, make it sure that the machine is running with a constant speed, that is a rated speed, and the field current is constant. Okay, we know that the flux is constant, and make it sure that the field current is constant and the machine is rotating with a constant speed. And if we increase the load from 0 to full load or no load to full load, the corresponding load current you can measure by using this ammeter, and the terminal voltage will appear across this voltmeter you can measure, and this terminal voltage includes two drops, IARA drop and demagnetizing effect of armature reaction, and then only you will get the terminal voltage. Okay, here you can see the characteristics curves for internal and external characteristics of separately excited DC generators. Here you can see the load current, and this axis the terminal voltage, you can see that, and three curves already I have drawn here, first, second and third curve, and this curve shows the ohmic drop, that is the voltage drop due to armature resistance, and this first curve is the curve for ideal characteristics. Ideal characteristics means if there is no voltage drop due to armature resistance, and if there is no voltage drop due to armature reaction, that means we will get the generated EMF at the terminal of the machine, because losses are absent here or drops are absent here, and this will be a constant from no load to full load. If we increase the load from no load to full load, the terminal voltage will be constant, and this terminal voltage V will be equal to the generated EMF, that is EG. Okay, but it is not practical. Practically it is not possible, so it is the ideal characteristics. And the second characteristics is the internal or total characteristics. This characteristics will give you the relation between E and IA, and this E includes the voltage drop due to armature reaction. Okay, so that it is slightly dropping from here to here due to what, the demagnetizing effect of armature reaction. Okay, so that is the internal characteristics of that separately excited generator, and the third curve will give you the external characteristics, that includes two drops, voltage drop due to armature resistance, that is IARA drop, and demagnetizing effect, two drops up to here, demagnetizing effect, and from here to here it is this shows ohmic drops. Okay, so we can say that the external characteristics is always lying just below the internal characteristics due to what, due to the ohmic drop or the voltage drop due to armature resistance. So that we can say that when we increase the load from no load to full load, the terminal voltage will be dropping like this. Okay, we cannot say that it is constant, because two drops will be there and it will be dropping like this. Here we can see that ohmic voltage drop. Okay, by considering this load current and the terminal voltage, this is the external characteristics. Okay, so these are the major points about the internal and external characteristics of separately excited DC generators. And for the selection of a particular separately excited generator, the important characteristics we must consider that is the external characteristics. Okay, thank you.